In today's lesson, we're going to be talking about reflections, translations, and stretches and shrinks of functions. So basically, given any function which we've talked about and studied, which passes the vertical line test, and so on, with changes to the equation, we can make reflections of the graph, translations, and stretches. So a couple of these that we're going to talk about. First of all, to reflect a function over the x-axis. So this would be moving this point in black right here to the point in red below it. And as you see when you do that, this is the 0.32, and it's being reflected to the 0.3, -2. So to reflect over the x-axis, we're basically changing the y. So the xy point is becoming x -y. Therefore, to reflect a function of y equals f of x, we would change the y to -y, which you can see we're doing right here. And then just to get y by itself, again, if we multiply both sides, this is the denotation for reflecting a function over the x-axis. That is basically multiplying the entire function by a -1. Likewise, to reflect something over the y-axis, you can see this is reflecting the 0.32 over the y-axis would become the point -32. So the x coordinate is changing, the y is staying the same, and so the new function would be y equals f of -x. I'm changing the x to -x. So this is the function, this is the rule that will reflect something over the y-axis. That something could be any function. Something we'll talk about, I won't ask you to graph any of these on today's assignment, but to reflect something over the y equals x line. Remember, the y equals x line is this main diagonal line with a slope of 1. To reflect over that, so in this case you can see I'm showing the 0.31. If I reflect it over that line, it would become the 0.13. So what's happening is the x is becoming the y and the y is becoming the x, which we show right here. And therefore, x equals f of y would reflect something over that main diagonal. Now, a couple examples. So if I give you a function, so this one is a v, it's an absolute value graph. Looks like the vertex is at the 0.41 approximately. And then I ask you to graph y equals -f of x. That -f of x multiplying by a negative, remember, is going to reflect this. This would be a reflection over the x-axis. So my new graph, that 0.41, would become 4 -1. And the other points would be reflected similarly, and you'd have that same shape graph just reflected over the x-axis. The second one here is y equals f of -x, x changing to -x. This we should recognize as a reflection over the y-axis. And so if I reflect this original function over the y-axis, that 0.41 is going to become -41. And the shape of the graph would stay the same. The whole thing is reflected over the y-axis. Here's a couple other examples. So here, y equals f of x. This is an interesting looking function. It does pass the vertical line test. All right, so to graph this, first one is y equals f of -x. Remember, this is a reflection over the y-axis. So the graph of this, I would reflect each of these points over the y. So what I'm going to do is look at these important points. So this point, which is negative 2, 0, would become 2, 0. The 0, 2 point, sorry about that, I hope you got that. Y equals negative f of x. Remember, this reflects over the x-axis. And so again, looking at those important points, that point negative 2, 0, if I reflect that over the x-axis, it would not change. The point 0, 2 reflected over the x-axis would become 0, negative 2. And then everything else would be flipped or reflected down. So my graph would look like this. And that's reflected over the x-axis. So those are our reflections over the x and over the y. I want you to be able to recognize which one's which, and then be able to show that on a particular graph. All right, the next part of this, we're going to be translating graphs. So this is moving graphs left, right, up, or down of a function. This will involve addition and subtraction. And if we have f of x plus 2, and this is on the inside of the parentheses, which is always going to be a left or right movement. Inside is moving it left to right or horizontally. And it's always opposite of what you think. So x plus 2, naturally you would think maybe 2 to the right. This is going to move the graph left 2. If I have f of x plus 2, so you can see that this plus 2 is on the outside of the parentheses, so that's going to affect it vertically or up or down, and it will do it exactly how you would think. So in this case, this plus 2 would move the graph up 2. Some other examples here, these are kind of combinations. Here we got x plus 3 on the inside, which would mean left 3, minus 1 on the outside, which would mean down 1. The last one here, we have f of x minus 1. That's 1 to the right, opposite of what you'd think, because it's on the inside. And minus 3 would move the graph down 3. All right, so some examples of these. So here we've got an absolute value graph. It's moved up 2. The graph of y equals f of x minus 2 on the inside. This is going to move this graph to right. So I can move that main vertex point 2 units to the right. And then my shape of this graph is going to be the same. It's not stretched at all. It's just translated, which means it's moved. This would be left 1 and down 3. So if I move that main vertex point 0, 2, move it left 1 and down 3, this would be my new vertex of this. And again, the shape of it would be the same. And it would look like that. It's being moved left 1 and down 3. This last one here, it's going to be right 3 and up 2. So this 0, 2 point, I'm going to move it right 3. I'm going to go up 2. That's my new vertex, would be 3, 2. And then again, the shape of the graph does not change. It'd be the same size. Here's another example. You can see that a little different shaped graph here with a couple important points. So y equals f of x minus 2. This is going to move this entire graph down 2. So I'm going to look at some of these important points. This negative 3, 0 point, if I move that down 2, I'd be at negative 3, negative 2. The point 0, negative 4 would be at now 0, negative 6. and the point 3, 0 would become 3, negative 2. So I'm moving everything down 2, and then the shape of the graph should stay the same. And it would look like this. So just moving the important points of the graph here. This particular function, this is going to move it left 3 and up 1. So I'm going to do the same thing, take those important points. That negative 3, 0 would move left 3 and up 1. It's over here at negative 6, 1 then. The point 0, negative 4 would become 3, left 3, and then down 1 would be 3, negative 5. And then the point 3, 0, left 3 would be 0, up 1, which would be right there. And then the shape of the graph would stay the same. And would look like this. Obviously the scale of my graph's not perfect, but the shape of the graph does not change. It's just being moved. This one here would be moved right 2. There's no up or down movement because there's nothing out here on the outside. I'm just going to move everything right 2. Again, starting with those same points. And then draw the shape. And I have translated that graph. So I hope this helps you complete the graph paper assignment for today. When you're done with that, there are videos for 4.2, 4.1, and the Chapter 3 summative, all good review to listen on your iPads, rewind and check, and help you get through those assignments.